Hi guys, it's Ash from Rally Raid. Just going to go through a cool project we've got on at the moment for the Himalayan 450. This is in line with Cooperb Motorcycles, which are in the next town over from us. They were one of the early adopters of Royal Enfield. Back when I bought my first Royal Enfield like 7 years ago, that was from them. So we are going to make a lowering link for the 450 Himalayan. So we have the OEM link here, and now we're going to go collect a 450 from them. We're going to try and make like a little prototype, just very simplified design, not including any of the bearings or the bush in the middle, and just try and get the 30mm reduction in height, in the seat height for some of the shorter riders. So we'll be going through the CAD and then kind of our development process, testing it on the bike, and yeah, give you a bit of insight on what our development process looks like, really. So our first step when we're reverse engineering something like this is we'll 3D scan this into our software. This will give us a pretty accurate model of the existing part. And you can export this as a 3D model, which we would then open up in our CAD software. Once that's in here, we can then superimpose our sketch of our new parts that we want to change over the top of the existing part. This allows us to not only pull dimensions from the initial parts, but also then modify them and change lengths. We can take measurements from the 3D model to our sketch to see how much we're adjusting it by. And then once we're done with this, we can then export our sketch to send to the laser cutters, where they'll laser cut our link arms. As you can see from the model, this is a machined center that's welded on to the laser cut parts. So we'll then also have our machinist make some centers up for us so we can weld them on for a prototype. We've just got one of our team members here on the bike, and this is the OEM linkage inside. You can see she's just on tiptoes at the moment, and she's a 31-inch inseam, so that will give us a reference point for the seat height of the bike at the moment. So we'll just head over to the linkage, show you what we're doing, and then we'll check the lowered state of the bike afterwards. So here we have the OEM link on the right, just all of the spare parts, so we can 3D scan the profile and just work out the shape of the laser cut pieces. And then for our prototype one, we have just started with a laser cut hole in the center for the bolt, just for ease of fitting to the bike and checking the seat height. So we took the bike in earlier in the month and just placed a 30mm piece of billet under the rear wheel and measured the difference in the hole spacings that the 30mm made. So that's about 9mm difference to this, which would then your linkage ratio equates to roughly 30mm at the rear wheel. So we'll just fit it to the bike now and see how that comes out. So we've just jacked the bike up now so that the rear wheel is just scraping on the floor. And now we're going to remove shock and linkage, and that will allow us to fit our one. And the theory is this distance here should be 30mm with our linking. Yep. Yeah, go on then. So now the link is fitted. We've got a 22mm parallel here that we can run under the tyre, so that just fits under, meaning that we're a few mil short of our 30mm target. So we'll now go back to the drawing and adjust the eye positions for the bolt holes and hopefully get our 30mm. So as we had the linkage in, we thought we'd still see what difference that 22mm has made. So as you can see, Amy is now comfortably on the balls of her feet instead of right on the tiptoes. So that'll give you an idea of how much difference that lowering of the bike makes. She was also able to easily push the bike over off that short side stand, which I know a few people have had an issue with. So hoping we'll kind of solve two problems with one product here. So we've just fitted our revised link, which should now give us our 30mm lowered height. So we've attached our sag meter here, which is zeroed with the wheel plenty off the floor. Now the idea is that when we now reinstall the OEM link, we should see roughly a 30mm increase on the travel of the wheel here, directly in line with the direction of the wheel going. So we've now reinstalled the OEM link, and our sag meter says 34mm of extra height with the OEM. So that means we're losing the 34mm when we put the lowered link in. So that is a job well done. So for more information on our release dates, prices and so on, just keep an eye on our blog. It will be linked below, and we'll hopefully have some more news for you soon. But yeah, cheers for watching.